Howdy Rock Buds, it's Rock Papa. Hope you guys are doing very well wherever you are in the world. Today I thought we'd have a look at some look-alike rocks that look similar to each other but really are formed by very different means. We'll look at pictures of these rocks and talk about how they're formed and give you some hints as far as distinguishing between them. So, hope this video is useful, and as usual, if so, please subscribe, and thank you so much to my excellent subscribers. I think about you all the time. So here we go, look-alike rocks. The first look-alike rock we have for you today is River Conglomerate. River Conglomerate is smooth river, rounded, mostly quartz pebbles in a matrix of sand and silt. As a stream flows, it smooths and rounds the pebbles, and because the pebbles are heavier than the sand, they accumulate on the bottom of the stream. Here's some river conglomerate that I photographed in the Big South Fork River in Big South Fork National Recreation Area. Notice how the pebbles are rounded and smooth because they spent a long time in the stream being rolled around. Also, notice all these pebbles are quartz. That's because feldspar, a very common mineral found along with quartz in granitic rocks, does not last long in the stream. Stream action breaks it down into very small particles, and they accumulate somewhere far down the river and form clay. Here's some river conglomerate from the Cumberland Plateau in Georgia with rounded, smooth hunks of quartz, and the matrix has a lot of iron in it, giving it a reddish color. Here's some river conglomerate from the Western Blue Ridge geologic province, and two things about it. Number one, see how big the pebbles can be, but they're rounded and smooth. Also, the matrix is gray, and since we know this river conglomerate formed during the late Precambrian as part of the Rodinia rifting process, we know the climate at that time was cold and wet, so that the iron in the matrix rock was not oxidized to a reddish color. And here's a funky drawing that I did just to show how river conglomerate forms in a river. This is a side view that shows the dark blue river water, and on the bottom you have the sandy matrix, and below that the pebbles that accumulate on the bottom. And here's just another side view of a stream profile showing the conglomerate pebbles down at the bottom of the stream. Why do they accumulate down there? Because they're heavier. Now let's take a look at a rock that I call Turbidite Sandstone. Turbidite Sandstone is made of rough-edged or angular hunks of quartz and feldspar embedded in a sand-silt matrix. Here's a piece of turbidite sandstone from that same Western Blue Ridge geologic province, and the thing to note here is that big white rectangular object is a hunk of feldspar. These big angular pieces of feldspar tell us something, namely that the source rock that this feldspar weathered from, which was more than likely granite or granite gneiss, was not very far to the place, the water-filled basin where this material was deposited. Otherwise, the feldspar would be smoothed off and really would have been eroded down to very tiny particles. Here's another piece of turbidite sandstone, and you can see angular white feldspar hunks and also blue hunks of quartz. Blue quartz tells us that this material was eroded from a ancient Precambrian basement rock that had experienced a lot of metamorphic pushing and shoving. Lots of metamorphism in a granitic rock encourages the accumulation of certain elements that give off this kind of a blue cast. Hey rock buds, why do I call this rock turbidite sandstone? Well, it is a turbidite deposit, and a turbidite deposit is material deposited in a basin that is all mixed up size-wise, from sand up to hunks of quartz and feldspar and even hunks of granite. The Geologists of Great Smoky Mountains National Park simply call it sandstone. For example, the Thunderhead Sandstone. That's confusing to me because by definition, sandstone, which is usually deposited by rivers and in sand dunes and that sort of thing, is equigranular. That means all the particles are about the same size and they are all made of sand, quartz sand usually. Well, turbidite sandstone is different from that, so I call it turbidite sandstone to distinguish it. Also, if this turbidite deposit has quartz and feldspar hunks that are smaller than, well, about the size of Abe Lincoln's ear on a penny, I call it gray whack or meta gray whack. If those hunks of quartz and feldspar, etc., are about the size of Abe's head on a penny, I call that turbidite sandstone. So I hope this helps you with some of the confusion about a rock that has different names. Turbidite deposits like turbidite sandstone and gray whack or meta gray whack are found in rift basins like the Rodinia rift basins. They're also found in subduction melanges where all the rock material gets pushed and shoved and all mixed up together, and at the base of the continental slope where the ocean, depth of the ocean goes from shallow at the continental shelf all the way down to very, very deep at the ocean basin. So in review, river conglomerate is formed in rivers, and the pebbles are mostly quartz and they're very well rounded and smooth, whereas turbidite sandstone and meta gray whack are formed in basins that rapidly fill up and with turbidity currents, and there can be quartz, feldspar, and even small granite hunks there, and they are angular in shape. Now let's take a look at Felsic Tough. It is made of felsic material ejected from a stratovolcano, and it's made of rough-edged or angular hunks of both felsic and mafic rock embedded in a fine felsic matrix. Here's some Felsic Tough, and you can see that the hunks that are embedded in the matrix are light-colored felsic and also darker-colored mafic pieces. And with Felsic Tough, the hunks can vary in size from very small up to about the size of your thumbnail, plus or minus. And here's a stratovolcano getting ready to blow. The stratovolcano is the typical kind of volcano that we think of when we think of volcanoes. And here's some examples of layers of Felsic Tough that were ejected out of a stratovolcano. And notice that the light-colored fine matrix is a felsic material. This is because during subduction, which creates a volcanic island chain or a volcanic continental chain full of stratovolcanoes, the subducting ocean crust goes down into the mantle where it melts, and felsic minerals like quartz and feldspar are the first to melt and rise up because they're less dense than the heavy iron rich mafic materials. These felsic materials come up into the volcano and plug it. They don't want to flow because they have these very strong quartz bonds, and so they resist the pressure until the pressure gets so great from below that there's a massive explosion, which is the hallmark of a stratovolcano. Next, let's take a look at volcanic breccia. Like Felsic Tough, volcanic breccia is material ejected from a stratovolcano. The difference from Felsic Tough is that in breccia, the matrix can be felsic or mafic, and the rock hunks can also be felsic or mafic, and they are large and angular in shape. So it's basically a matter of the size of the rock hunks that come out. Here's a really nice piece of meta breccia that I found in Colorado, not too far from the Mountain of the Holy Cross. The matrix material looks to be pretty mafic, and the largest hunks, which are quartz, are very angular and maybe about 1.5 inches or 2 inches across. Here's some more volcanic breccia with pretty good sized hunks that are both felsic and mafic. And this picture shows you just how big volcanic breccia rocks can be. This is the West Elk breccia, which is found in the West Elk Mountains of Colorado. Hey guys, one of the very best ways to distinguish between these look-alike rocks is geologic context. So learning the geologic history of the area where you're collecting will be a really indispensable tool for you. And also having a good app, a good geologic resource at your disposal, like the Rock D app, that will tell you generally what kind of rocks you find in an area. That's going to help a whole lot too. So I hope these helpful hints will help you distinguish between these look-alike rocks. There's another interesting kind of breccia that we can look at called Breta Pipes. Let's say you have a layer of limestone like maybe the Knox limestone in the eastern U.S. and volcanic activity nearby pumps valuable metals like copper, zinc, lead, etc. into this limestone. Then the action of water, which is a weak acid and dissolves the limestone, which is a weak base, makes these holes in the limestone, and the caprock that is overlaying the limestone collapses, and all this material along with the valuable metals collapses and fills up this hole, forming a cylindrical body of breccia. This light-colored column of breccia is something that you see in a lot of the pictures of the Grand Canyon, and it formed in the Redwall limestone, which was laid down during the Mississippian period. There are a lot of these breccia pipes, especially around the south rim of the Grand Canyon, and they contain copper and uranium, which was mined pretty intensively in this area before it became a national park. Here's some greenish copper-rich breccia, and notice the angular hunks. Now let's take a peek at Lahar, another volcanic-induced kind of formation. Lahars form when the stratovolcano erupts and forms a mass of flowing hot mud and hot water, hot rocks down a stream bed usually, that is extremely destructive, knocking down trees and moving huge boulders down the stream. Here is Spirit Lake with Mount St. Helens in the background after it erupted, sending lahars down streams and into the lake that filled it with millions and millions of tons of lahar material and whole forests of trees. Lahar rock has a fine-grained matrix of mud that's filled with rocks of all sizes, both angular and smooth. The angular breccia rocks blasted from the volcano, as well as rounded river rocks that the lahar picked up on its way down. Okay, most excellent rock buds, that's enough look-alike rocks for now. Thank you so much for watching, and once again, if this was useful, please subscribe. Thank you to all my subscribers, and this is your Rock Papa saying happy rock hunting to all my wonderful rock buds. Papa out.